Okay? Now, how would the answers change if the truck was going up at an angle of 20 degrees? So let's do that. Let's just redo everything. If the truck is going up at 20 degrees. So what's the minimum static friction that you need? So now we have the box, the forces on the box. Mu Sn mg n mg cos theta mg sine theta. So again, we have a case where the friction is what's causing the box to accelerate up. So we have here the acceleration is up. So mu Sn minus mg sine theta is equal to ma. N is equal to mg cos theta. M cancel. Mu s is what we're solving for. G is 9.8 cosine, and then let's say the angle of inclination is 20 degrees. We should get a bigger answer, right? It should take more coefficient of friction to accelerate up the incline. So cosine of 20 minus 9.8 sine of 20. So this is the downward component of the weight of gravity. Normal force, the static friction force needed. The acceleration, we want it to be equal to 4. Mu s minimum 0.798. Okay, this one goes up to the over here. You add it, and then you divide by 9.8 cosine 20. So we got 0.798. So it requires a lot more. Oh, that's about double, right? Double the static coefficient of friction to accelerate up. Now, what if mu s is less than that? What's going to be the acceleration? Okay, so let's still assume mu k is 0.1. Okay, so now we're going to change this to mu k. It's going to go up, mu k, mu k, mu k. Change everything to mu k, and now put this 0.1. So this time we're calculating for the acceleration, right? So we don't have to sort of redo everything. We already have pretty much the works. We're changing this to mu k, 0.1, 9.8 cosine 20, and then here we're solving for the acceleration. Okay? So we have 0.1 times 9.8, negative 2.43 meters per second squared. Okay, so what does that mean? Well, that means even to a person outside of the box, the box is going to accelerate down. Okay, so as soon as you put it over there, it's going, the thing is already accelerating down. So according to someone in the box outside, the box is already going to accelerate down. Okay, so according to the truck, of course the box is going to accelerate even more down, right? So the acceleration prime of the box with respect to the truck is negative 2.43 minus 4. Because the difference of the two. Remember when they were both forward, we took their difference, it was 0.98 and 4, the difference was 3.02. So now the acceleration is down 2.43 and that acceleration is up, so with respect to the truck, negative 2.43 minus 4, negative 6.43 meters per second squared. The acceleration of the box with respect to the truck. So how long is it going to take the box to hit the back of the truck? Right away. Right away. So you have distance is equal to half at squared. The distance is 2 meters. Take the absolute value of that. Okay. 4 divided by 6.43 to the power 0.5. 0.7887 seconds. The other one took 1.15 seconds, right? 1.15 seconds, a little bit more than 1. This is 0.2 seconds less than 1. So right away, the box is going to hit the back of the truck. So how much has the truck moved? Well, you could do the same kind of calculation. How far has the truck moved in the meantime? You could do distance is equal to V initial t plus half AT squared. V initial, let's say it was still 2, it's 0.7887 plus half times 4 times 0.7887 squared. 2 times 0.7887 plus 2 times 0.7887 squared. 2.82 meters. So the distance of the truck with respect to a person on the outside is going to be 2.82 meters. The truck hasn't traveled as far up because the box hit the back of the truck right away. How far do you think the distance of the box will be to a person on the outside? Well, it's got to be 2 meters less than that, right? So 0.82 meters. So if you calculate it with the same initial velocity and the time and the acceleration of the box, you should find that it's 0.82 meters. Okay? So it's got to be 2 meters less than that, and it should be 0.82 meters. So you can see here, this is a really, really good example of a couple of things here. You can see the friction is forward. It's helping the box. It's trying to help the box to accelerate. So it illustrates that. And then it also shows the difference of what happens when something is on a level plane versus on an incline. So you can kind of analyze that. You can also do this one a downward incline. What should be the acceleration? What should be the μs? So repeat the problem with a downward inclination and an upward inclination and see the differences. So a very, very good problem. Thank you.